This part of the video deals with two thermochemical experiments. One is determination of heat capacity of the calorimeter and the second is determination of integral enthalpy of solution for a given solute dissolved in water.
The apparatus required in the thermochemical experiments are a thermos flask with a lid having two holes, two thermometers with the least count of 0.1 degrees Celsius, that is, they can measure a temperature difference of 0.1 degrees Celsius. We also require a stirrer, a burette, a funnel, a clamp and stand, a stopwatch to note the time, a tripod stand, a wire gauze and a burner for heating. The solution to be used in the thermochemical experiment is taken in the thermos flask. Then the thermometer and the stirrer are dipped in the thermos flask and the lid of the thermos flask is closed. This entire setup is known as calorimeter. We can use another type of setup for the calorimeter, and that includes a plastic bucket with a lid having two holes. The plastic bucket should have thick walls. We also require a thermocol block. The solution is taken in a 250 ml beaker and kept inside the bucket on a thermocol block. The thermometer and the stirrer are inserted through the holes and they are dipped in the solution. The lid is closed and this is the complete setup for the calorimeter. Procedure. The first step in all the thermochemical measurements is the calibration of the two thermometers. For this, one thermometer is labeled as thermometer A and the second thermometer is labeled as thermometer B. The bulb of the two thermometers are dipped in water at room temperature and their readings are noted. Then hot water is taken. The two thermometers are again dipped in the hot water and their readings are noted. The difference in the thermometer readings are noted for both the samples of water. The average of the difference is calculated and we assume that thermometer A shows the correct reading and thermometer B shows the incorrect reading. So the correction is applied to the readings of thermometer B, but these corrections are applied during the calculations and not during the measurements of the readings. Second step, measurement of the heat capacity of the calorimeter. For this, take 50 ml of distilled water in the thermos flask from the burette. Then thermometer A and the stirrer are dipped in the flask. The lid is closed. This water is taken as cold water. Now to take hot water, 50 ml of distilled water is taken in a beaker from the burette and it is kept for heating. When the temperature of the water becomes about 20 degrees above room temperature, then the heating is stopped. The beaker is then kept near the calorimeter. The hot water is kept in the beaker. Thermometer B is dipped in the hot water. Thermometer A is dipped in the calorimeter. The record book is kept ready. Then you hold a stopwatch in your left hand and start noting down the temperature of the thermometers. For that, start the stopwatch and note down the temperature of hot water. This is the temperature at 0 time. Then after 20 seconds, note down the temperature of cold water in the calorimeter. Note down the temperature of hot water and cold water at an interval of 20 seconds for 3 minutes. Now, when the 3 minutes are over, then open the lid of the calorimeter. Remove thermometer B from hot water and pour the hot water into the calorimeter. Note the exact time when the hot water was added to the calorimeter. Immediately close the lid of the thermos flask. Stir gently and again start noting down the temperature of the mixed water. Note the temperature of mixed water at an interval of 20 seconds for 4 to 5 minutes after mixing. After 5 minutes, the experiment is over, so you can stop the stopwatch. Now plot a graph of temperature versus time for hot water, cold water and the mixed water. Draw a perpendicular at the time of mixing on the x-axis. Extrapolate the 3 curves to meet the perpendicular. This will give you the temperature of hot water, the temperature of cold water and the temperature of mixed water at the time of mixing. Substitute these values in the formula mentioned before and calculate the heat capacity of the calorimeter. Some important precautions that you should take while doing the experiment. The first thing is the calibration of the thermometers should be done carefully. While noting down the temperature, the thermometer bulb should not be removed from the solutions. The next thing is that the lid of the thermos flask should be kept closed when the readings are being taken. The time of mixing should be noted very accurately and the mixing should be done properly. The next part of the experiment is the measurement of the integral enthalpy of solution. Most of the apparatus required for this experiment is same as the apparatus required for the measurement of heat capacity of the calorimeter. In addition, we also require a weighing tube, a petri dish and a spatula, as well as the salt. The procedure for the measurement of the integral heat of solution. The first step is calibration of thermometers. The second step is measurement of the heat capacity of the calorimeter, and then we measure the integral heat of solution. Take 100 ml of distilled water in the thermos flask from the burette and insert a thermometer and a stirrer in it like we did in the previous experiment. Then take the crushed salt to be used in the experiment. Take a clean and dry weighing tube and find the mass of the empty weighing tube. Then, after finding the mass of the empty weighing tube, transfer the required amount of salt to the weighing tube. Then, find the mass of the weighing tube by weighing it on the balance. To make the measurements, keep the salt near the calorimeter, keep the stopwatch and the record book ready. Start the stopwatch and note down the temperature of water in the calorimeter. Keep on noting down the temperature of water at an interval of 20 seconds for 3 minutes. When the 3 minutes are over, open the lid of the calorimeter and transfer the salt into the calorimeter. Tap to transfer the maximum amount of salt. Note the time of mixing. Close the lid immediately and stir gently to dissolve the salt. When the salt has dissolved completely, again start noting down the temperature after mixing. Keep on noting the temperature of the solution at an interval of 20 seconds for 4 to 5 minutes after mixing. After 4 to 5 minutes, the experiment is over. Now, find the mass of the empty weighing tube and the residual salt to calculate the exact amount of salt that has been transferred. Plot the graph of temperature versus time. Draw a perpendicular to the x-axis at the time of mixing. Extrapolate the curves to meet the perpendicular and find out the temperature of water and the solution at the time of mixing. Substitute in the formula and calculate the integral heat of solution.